Hello, in this video I'll be showing you how to answer the NSAA 2017, Section 1, Question 43. Solid copper chloride contains copper 2 plus and Cl minus ions only. Solid lithium phosphate contains lithium plus and PO4 3 minus ions only. Aqueous solutions of both are mixed to produce a precipitate of copper phosphate and an aqueous solution of lithium chloride. Which of the following represents the balanced ionic equation for this process? So let's remind ourselves what an ionic equation is. So an ionic equation is a chemical equation where the electrolytes in aqueous solutions are written as the dissociated ions. So we will now look at each equation in turn. So for our first equation A, we have Cu2 plus 2 electrons goes to the copper metal. But our question here says we have a precipitate of copper phosphate, not copper metal. So this equation is wrong. So for equation B, we have our dissociated ions and a precipitate. But this is in fact the wrong precipitate, as we have copper 2 plus and the phosphate 3 minus. So this will give you a precipitate of Cu3 PO4 2, not Cu2 PO4 3. So equation B is incorrect. So for equation C, again, looking at precipitate, we have the incorrect precipitate. So equation C is also incorrect. So looking at equation D, now we have our correct precipitate. And we have the electrolytes in aqueous solution are written as the associated ions, and the equation is all nicely balanced. So equation D here is correct. I'll carry on going through E and F to show you why they're wrong. So the reason why E is incorrect is that you have lithium chloride in aqueous solution, and this should be written out as its dissociated ions, as we have here. And when you do so, they will cancel out and they will give you D. Lithium and plus and chlorine minus are said to be spectator ions. They don't take part in the reaction. Similarly for F, we have copper chloride in aqueous solution, lithium phosphate in aqueous solution, and lithium chloride in aqueous solution. These should all be written out as the dissociated ions.